Welcome back to IB ESS. This is Biodiversity, Origins and Threats, topics 3.1 through 3.3. Where biodiversity comes from, how it's measured, and why we're losing it at an alarming rate. Let's go. Biodiversity has three nested scales. Outermost, ecosystem diversity, the range of different habitats, rainforests, coral reefs, grasslands. Middle, species diversity, how many species live there. Innermost, genetic diversity, variation within a species. For the exam, you'll need examples at all three levels. Think coral reef, multiple ecosystems, thousands of species, millions of genes. Simpson's index quantifies species diversity in one number. The formula: D equals n minus 1 divided by sigma n of n minus 1. It sounds scary, but here's the logic. High D equals low diversity. Low D equals high diversity. Counterintuitive? Yes. That's why examiners love testing it. A meadow with 60 species scores D equals 2.69. Low diversity value, actually high species richness. A monoculture scores much higher. Watch out for that flip. Life exploded over deep time. Natural selection drives this. 4 mechanisms. Variation. Random mutations create differences. Selection pressure. Environment favors some traits. Differential survival. The fittest reproduce more. Inheritance. Advantageous traits pass on. Over millions of years, tiny changes compound into new species. Look at those birds on screen. Same ancestor, different beaks. That's natural selection in action. Speciation happens in 4 stages. 1. Original population. One species, gene flow everywhere. 2. Geographic isolation. Physical barrier splits the population. No interbreeding. 3. Divergence. Different selection pressures drive genetic drift. 4. New species emerge. Reproductive isolation completes. The barrier could be plate tectonics splitting continents, sea level change isolating islands, or mountains creating separate valleys. Continents drift. 90 million years ago, Africa and South America were neighbors. Today, separated. Look at the stats on screen. 36 biodiversity hotspots exist on Earth, just 2.5% of surface, yet 44% of plant species. These hotspots often coincide with isolated land masses. Australia, Madagascar. Plate tectonics created them. Isolation preserved them. This is exam gold. Link geology to ecology. Earth has survived 5 mass extinctions. The last? 66 million years ago, the asteroid that killed the dinosaurs. Today we're in the 6th, and this time, we're the asteroid. The extinction rate now, 100 to 1,000 times background rate. In the last 50 years, 42,000 species assessed, 28% threatened. The IUCN Red List tracks them all. We're losing biodiversity faster than we discover it. 5 direct threats. Habitat loss, the biggest driver. 10,000 square kilometers per year gone. Invasive species, cane toads in Australia, zebra mussels in North America, outcompete natives. Overexploitation, we catch, hunt, or harvest faster than populations recover. 97% of Atlantic bluefin stocks depleted. Pollution, pesticides, plastics, microplastics. Climate change, rapid warming outpaces species' ability to adapt. Know these 5. Examiners ask about them constantly. The pyramid shows risk tiers. Top, EX, extinct. Below, EW, extinct in the wild, only survive in zoos. Then CR, critically endangered. EN, endangered. VU, vulnerable. At the base, LC, least concern. 150,000 species assessed, 42,000 threatened. The rhino you see on screen? Critically endangered. 1,000 individuals remain in the wild. Knowing this framework matters for exam essays. Direct threats don't appear in a vacuum. Root causes. Human population growth drives demand for food, fuel, land. Economic systems prioritize profit over conservation. Agriculture expands, forests fall. Industrialization pollutes, governance fails to regulate. Look at this city from space at night. Light pollution from 1 billion humans. Population and consumption are the invisible drivers behind every threat you just learned. Why does biodiversity matter? 4 reasons on screen. Provisioning. Food, water, medicines. 75% of food crops depend on pollinators. Regulating. Climate, water purification, disease control. Supporting. Nutrient cycling, soil formation. Cultural. Recreation, spiritual value, beauty. Here's the exam angle. Biodiversity loss equals ecosystem service loss equals direct impact on human well-being. That's how you make conservation arguments quantitative. Master these 9 ideas. 3 levels of biodiversity, Simpson's index, and what low D means. Natural selection and speciation. Geographic isolation and reproductive isolation. Plate tectonics creating hotspots. 5 mass extinctions, 6th extinction happening now. Direct threats, HIPCC, habitat, invasive, pollution, climate, overexploitation. IUCN categories. Ecosystem services. Know these and you'll ace every question. 2 questions here. Short answer and extended response. Q1 asks about a forest survey. Read Simpson's D. Explain what it means. Compare biodiversity between 2 sites. Q2 evaluates threats to biodiversity. Define habitat loss. Give Amazon and Borneo examples. Compare invasive species impact. You've learned where biodiversity comes from, how it's measured, and why we're losing it. Next video, how we protect it. Conservation strategies, international agreements, and real-world case studies that show what works. Stay tuned. 847 words.